Hi, my name is Ritika, and today I'll be presenting our latest paper, RankT2I, a submodular framework for discovering interpretable and diverse semantics in text-to-image models. This work was recently accepted to ECCV 2026 and will be presented in Malmö, Sweden. As you all know, text-to-image models have greatly advanced image generation and editing. However, it is still difficult to determine which semantics a model can actually edit in an image. Current methods often require users to manually test different prompts, which is time-consuming and involves trial and error. As seen in the figure on this slide, some semantics in text-to-image models work successfully, such as changing a dress's color to hot pink. However, other edits fail, such as adding a tulip hem to a dress. This highlights an important issue. Text-to-image models have different editing capabilities and limitations, and we need an efficient way to discover them. To address this challenge, we introduced RankT2I, a training-free and model-agnostic framework for automatically discovering and ranking diverse and editable semantics in text-to-image models. We treat semantic discovery as a set selection problem and use a submodular objective to find semantics that are relevant, editable, and diverse by the underlying text-to-image model. Our method uses text prompts along with original and edited images to identify meaningful semantics. Overall, our results show that RankT2I generally outperforms existing diffusion and flux-based semantic discovery methods across various domains in much less time. Now, I will briefly go over how our method works. First, we use a multimodal vision language model to generate a list of potentially editable semantics for a given domain. Next, we provide these semantics and a set of original images to a text-to-image model to generate the corresponding edited images. Finally, RankT2I takes the candidate semantics, original images, and edited images as inputs and identifies and ranks the semantics that are relevant, editable, and diverse. More details regarding the equations RankT2I uses can be found in our paper. Now that I've briefly covered our methodology, I'll move on to the results. As seen in this figure, RankT2I can identify various semantics across different domains, such as different accessories for an image of a pet or toppings for an image of a cupcake. Additionally, in our paper, we compare RankT2I to other semantic discovery methods. Specifically, for flux-based methods, we compare RankT2I to slider space. For example, as seen in the cities domain, our method identifies semantics such as adding a dense crowd or billboards to an image. Compared to RankT2I, slider space appears to include semantics that tend to change the overall color tone for this particular example. We also compare RankT2I with existing diffusion-based semantic discovery methods like noise clear and slider space. In this example, in the face domain, RankT2I discovers edits such as hair color, shirt color, and mustache styles, while noise clear appears to include repetitive semantics such as adding a green tie, and slider space appears to change the person's identity. Overall, these results demonstrate that RankT2I can discover a wider range of disentangled semantics in diffusion-based text-to-image models. Also, we compare the time it takes for our method to discover 100 semantics to noise clear and slider space. Regardless of the base model, RankT2I takes significantly less time to find semantics for image editing. This disparity in the total time can primarily be attributed to the training-free nature of our method. Furthermore, we evaluated the diversity and interpretability of the discovered semantics using various metrics. As seen in this table, RankT2I is able to find a balance between diverse and interpretable semantics, consistently outperforming noise clear and slider space across these metrics. In conclusion, we present RankT2I, a submodular framework for discovering diverse, editable, and relevant semantics in text-to-image models. Our approach can be applied to a wide range of text-to-image editing models, including diffusion-based and flux-based models. RankT2I is also training-free, which makes the semantic discovery process much faster and more efficient. We hope that our work can support a wide range of editing applications for users, from stylistic image transformations to fine-grained object and scene-level editing. Thank you for listening. If you're interested in more details and additional experiments, please check out our paper.